Good morning, class. Welcome to Molarity Review with Mr. V. Since today is review, there's some things we already know. One thing we know is molar mass. And we know we get that from the periodic table. If we were to look at the periodic table and look for carbon, we know that carbon has an atomic number of 6 and it has the molar mass of 12.01. What this means is that 1 mole of carbon is equal to 12.01 grams. That's why it's known as the molar mass. Taking the molar mass, it lets us get from moles to grams and grams to moles. Now, to go from moles to grams and grams to moles, we do two different things. To go from moles to grams, we multiply. And to go from grams to moles, we divide. But what do we divide with? What we end up doing is finding the molar mass of the compound or atoms or molecules, whatever it is that we are working with. We find the molar mass and we use that molar mass to multiply or to divide to get, depending if we want to go from moles to grams or grams to moles. Something we also know is that 1 liter equals 1,000 milliliters, or that 1,000 milliliters is equal to 1 liter. For example, if we were given 250 milliliters and we wanted to get to liters, what do? So we've done this a couple times. So what we do is we get 250 milliliters and divide it by 1,000. With that, we end up getting 0.250 liters. Now, this is something you just have to practice, so the more practice you get, the better you're going to be. So the reason you end up with liters is because the milliliters cancel out, and the milliliters is the only thing left over. And finally, the last thing we know is our molarity equation. Molarity is depicted as a capital M, and what it equals is the moles of solute over liters of solution. Now, let me fix that real quick. Alright, we just use this equation to plug things in. We gotta find the moles and we gotta find the liters. Here we have two examples. We have an easy example and a challenging example. One of them is a little bit more simpler than the other one because of what the equation gives you. So let's start with the first one. What is the molarity of a solution that contains 4.53 moles of lithium nitrate in 2.85 liters of solution? The first thing we need to do is use our molarity formula. So molarity again is equal to the moles of solute over liters of solution. Now, whenever we work on a molarity formula, we need to do 3 steps. So one is get to the mole. For this one, we're given 4.53 moles of lithium nitrate. That is also our solute. So, since we're already at moles, we just plug that into the top of the formula. So we have 4.53 moles. Great. Our second step is to get to liters. In this equation, we're given 2.85 liters of solution. We're already at liters, so we just have to plug it into the equation. 2.85 liters. Now, if we were to plug and chug that, that's our third step. So molarity, plug, and chug. Now if we were to use our calculators and crank this out, we would end up with a 1.58 molar solution. Oh, that's gross. Better. That first one was pretty easy, right? Just a plug and chug. Here we have our challenging example. This one's going to require a couple more steps, but it's actually not too bad. What is the molarity of a solution that contains 87.0 grams of potassium chloride dissolved in 300 milliliters of solution? The first thing we always have to do is start off with our molarity formula. Our molarity formula is moles of solute over liters of solution. Now we're given all the information in the equation, just that we have to do a little bit more work to get to it. So one of the very first step is to get to the mole. Now we were given from solute 87 grams of potassium chloride. What we do is something we've always done before. So we're given 87 grams of potassium chloride. Now to go from grams to moles, what do? We end up dividing by the molar mass of the solute, which we have potassium chloride. If you're to add up look in your periodic table and look for the weight for potassium, it's 39.1. If you look up the molar mass for chlorine, it's 35.45. If you were to add that up, you would get 74.46 grams. Since we're going from grams to moles, we end up dividing to get the moles. So if you crank that out on your calculator, you get 1.16 moles of potassium chloride. With this, we have our first part of the equation. We can plug that in a little later. The second part of the equation is the get to liters part. So 2 get to liters. Now in the equation we were given 300 milliliters of solution. We're given 300 milliliters, but we need liters. Now in our previous example, in our liters, we know that 1,000 milliliters equals 1 liter. So if we want to go from milliliters to liters, we need to divide it by 1,000. Now what happens is that these units cancel out and we're left out with liters. So if we were to crank that on our calculator, we'd end up with 0.300 liters. Now we have both parts of our equation. We have the moles, check, and we have our liters. So now we do our final step, is molarity. Plug and chug. Let's bring this information to our equation. So moles or solute is 1.16 moles. And our liters of solution is 0.300 liters. Now we need to put this in our calculator. If we take 1.16 moles of potassium chloride and divide it by 0.300 liters, we end up with 3.866, meaning that we have a 3.866 molar solution. And we're done. So that's our answer. So if you want to use this example, it'll be on my website, which I will tell you about right now.